Alright, so number 5, you have a another vertex form, quadratic. The h is -2 and the k is 0 because there's nothing here. So that's your vertex. Let me just write it out right here, -2, 0. It concaves up, so it has a minimum value of 0. And the domain is all reals. And the range is from 0 to infinity. Okay, to get the y-intercept, we replace the x with a 0, so we're looking for f of 0, which is, you know, the y value. So that's going to be 1/2 0 plus 2 squared. So 0 plus 2 is 2, 2 squared is 4, so half of 4 is 2. So when x is 0, y is 2. Okay, and x-intercept, because the vertex is on the x-axis, that's your x-intercept. So this is one of those cases where you only have one x-intercept. Okay, so that's going to be -2, 0. So we plot this, -2, 0. 0, 2 is the y-intercept. And because of the symmetry with parabolas, we know that -4, 2 is also on the graph. Okay, because parabolas are symmetric. And there's your graph right there. It's a little lopsided, but it's good enough. Okay, number 6, the h is -3 and the k is 5. So the vertex is -3, 0. I'm sorry, -3, 5. So you have -3, 5. It concaves down, so it has a maximum value. The maximum value is 5. The domain is all reals. And the range goes from -infinity to 5. To get the y-intercept, we set the x equal to 0 and solve for y. So we're looking for f of 0. F of 0 is -2 times 0 plus 3 squared plus 5. So 0 plus 3 is 3. 3 squared is 9. 9 times -2 is -18. Plus 5 is -13. So this is -13. So we're not going to see this point on the graph, okay, because our graph doesn't reach that far. That's okay, but it's still important to know the value. The x-intercept, we make the f of x equal to 0, and then solve for x. So x plus 3, subtract 5. And at first you might think, oh, no x-intercept because of the negative, right? But this, you're going to divide both sides by -2. So that's going to make it a positive over here. Okay, and this is gone. And so you have 5 halves, or 2.5. So we're going to take the square root of both sides. So you have plus or minus the square root of 2.5 equals x plus 3. And so you subtract 3 from both sides. So -3 plus or minus the square root of 2.5 is x. And right here you have your two x-intercepts. Okay? Because the plus and minus accounts for the 2. So one of them would be -3 plus square root of 2.5. The other one is -3 minus the square root of 2.5. So when you write it out, you can write it as a single like parentheses, because when you put the plus minus, that's telling me, okay, it's both of them. So 2.5, make sure that's in there, comma 0. Okay, so when you plot it, it's going to go down, remember, vertex is -3, 5. And you could take a calculator to get the approximate value of the x-intercepts if you want. Or you can just pick another number, I'll say -2, and plug it in for x, substitute it for x, and solve for y. So I'll just try 2. So I'm going to put -2 times -2 plus 3 squared plus 5. So that's going to give you 1 right here, times negative 2 is negative 2, so that's 5 minus 2 is 3. So right here I have a point at negative 2, 3, and because of symmetry I know that negative 4, 3 also exists without the need of doing any more calculations. You could do the same thing with negative 1. X is negative 1, so I'm going to put negative 1 plus 3 squared plus 5. So this is 2, square root is 4, 4 times negative 2 is negative 8, so negative 8 plus 5 is negative 3. So right here I have a negative 3. Because of symmetry, I know that negative 5, negative 3 also exists on this graph. And so there's the function. Okay. Alright, so number 7 is in standard form. I know that it concaves up because A is positive, so I know it's going to have a minimum value. I know that the domain is all reals, and another thing I know without doing much is that the y-intercept is negative 5. So 0, negative 5. Okay, so I need the vertex, right? So I'm going to put, for the vertex, x equals negative b over 2a. So that's going to be negative 4 over 2 times 1. So that's negative 2. And so I replace the x's with negative 2 so that I can find the y. So that's negative 2 squared plus 4 times negative 2 minus 5. So that gives me 4 minus 8 minus 5. So that gives me negative 9. So my vertex is going to be negative 2, negative 9. Okay? So then that gives me my minimum value. My minimum value is negative 9, and my range is from negative 9 to infinity. Okay, so x-intercepts. X-intercepts, you try to factor first, see if it factors. And so I have factors of negative 5 that add up to 4 are 5 and negative 1. So this factors as x plus 5 times the quantity of x minus 1. So when you distribute, you get the original back. So this is f of x right here. So my x-intercepts are negative 5, 0, and 1, 0. The p and the q right here. Here's the p, negative 5, here's the q, 1. So now we're going to graph it. So negative 2, negative 9. So it's going to be about approximately right here. And then y-intercepts are negative 5, 0 to 4 about here, and then 1, 0. Y-intercept is 0, negative 5, so about here. And if 0, negative 5 is on the graph, then you know that negative 4, negative 5 is also on the graph. Okay, because of symmetry. And then you connect. And there you have it. Number 8. Another one that concaves up, right? So that means that you are going to have a minimum value. The domain is all reals, and the y-intercept is 0, 3. Okay, and we get the 3 from the c value right here. Okay, I'm going to go ahead and find the vertex. Vertex is x equals negative b over 2a. So that's negative 6 over 2 times 3. So that gives you negative 1. And so y equals 3 times negative 1 squared plus 6 times negative 1 plus 3. So negative 1 squared is 1 times 3 is 3. And then this gives me negative 6. And then this gives me plus 3. So 6 minus 6 is 0. So I have negative 1, 0 as my vertex. And notice negative 1, 0 is on the x-axis, so that means that makes that one the x-intercept, and there's only one. Okay? The minimum value is 0, and the range is from 0 to infinity. Okay, so let's go ahead and plot this. So it's going to be negative 1, 0 right here. the y-intercept is 0, 3. And so because 0, 3 is on the graph, then I know for a fact that negative 2, 3 is also on the graph because of symmetry. And then just connect your points. It's going to be a skinny parabola, and we knew that even before because the a value is 3, so there's a vertical stretch.